So I just wanted to include a little addendum for people that are interested in one thing that I sort of skipped over, and that's the difference between primitive recursive and recursive. So I recorded this kind of thing in the middle, so I'm just going to let it go. There's a bit of a hiccup here, which you probably noticed maybe, which is that if you scroll up and we go back to this comparison, if r is equal to delta 1, then there's a bit of a discrepancy between this computable version and this definable sets version, because at the bottom here is delta 0 formulas, and up here is computable formulas. So there's a little to say there, and again, there's this topic of primitive recursion, and I think maybe it's unavoidable that I say a few things about it. So what's the difference between delta 0 and delta 1? This is a bit of a difficult thing for people that are new to this theory. What's the difference between delta 0 versus delta 1? I want to say something about that. So basically, your delta 0, right? Basically what we're saying, and I think this is probably the best way to actually explain the difference between primitive recursive and recursive, which is something that confuses people that are in computability theory. I think maybe pulling from the definability stuff makes it easier to understand, because delta 0 versus delta 1 is a very clear difference in the number theory sense, right? The number theory sense is that you only have bounded quantifiers. If you only have bounded quantifiers, then that means that you never at any point have to say anything in your code like, while this isn't true, do this. If I say something like that in my code, then I'm not really specifying when it should stop. I just am assuming, based on how I designed my code, that it will eventually stop. Whereas here, with these delta 0 formulas, I'm explicitly, I will never have to do that. I will never have to say, while something that I don't know when it will end ends, do something. I will always be able to use for loops, essentially. I will always be able to say, do this exactly up to this point and no further. That's the difference between delta 0 and that's delta 1. And that's the difference between primitive recursive and recursive. If you're recursive, and let's not say recursive, let's say or computable. Let's actually look back up and look at the delta 1 formulas. You're a delta 1 formula if you're equivalent to both a sigma 1 formula and a pi 1 formula. And so what's going on there? Well, remember, we said that sigma 1 intersect pi 1. We actually noted that that was obviously equal to r. That was obviously a set of all computable problems. And how did we do that? We did that by going back and forth between the sigma 1 and the pi 1 algorithm for the language in delta 1. We said that if you have a decision problem in delta 1, if you have a decision problem in both this and this, then there's a machine that decides the yes answer. There's the machine that will eventually accept the yes answers and a machine that will eventually accept the no answers. And so if you just run both back and forth, then eventually you will arrive at a yes or no answer, and you're sure of it. But note the defining feature of that. We can now note the defining feature of that. The defining feature of that versus delta 0 is that even though I know it will end, I don't know when it will end. So here's the big difference. Delta 0, which represents the primitive computable problems. Primitive computable. Primitive computable, you should kind of take as meaning, I know when it will end. That's a stronger version of knowing that it will end. If you have the regular computable, then you have something a little stronger. You're basically just saying, I know that it will end. I don't know when necessarily. And there's a big question, are those different? If I can, like, it's tempting to think that, there might be some theorem that says, if I always have an algorithm that tells me that it will end, then I can always kind of like, redesign an algorithm that knows exactly how many, that doesn't need any like undetermined while loops, right? But that's actually not true. These are not the same class. But they are similar enough that putting delta 0 here instead of delta 1 doesn't do anything. It doesn't make any difference. Because, yeah, it doesn't make any difference, basically, to put delta 0 here versus delta 1. And I don't think I could have said that responsibly without explaining the difference between them. If you explain the difference between them, then I think it is clear that putting this here instead of delta 1 isn't that big of a deal. And it isn't that big of a deal. It turns out that you get the same arithmetic hierarchy regardless. So I guess what the takeaway is that here that you could define the arithmetic hierarchy just as well by crossing this out and writing instead primitive computable or primitive recursive. That's kind of the takeaway. Again, it's weird because we're learning things back and forth by going back and forth between like metamathematic number theory stuff and computability stuff, but it actually, I think, does serve to clarify certain things that confuse a lot of computability theorists. And the computability stuff helps to clarify a lot of things that confuse a lot of the logicians. But, you know, we're doing it from both ends, and so certain things become obvious.